Hello, everyone, and thank you for coming to today's webinar. We're going to be talking about how Pinterest modernized their iOS build infrastructure with Amazon EC2 Mac instances. My name is Scott Malky. I am a specialist SA on the EC2 team, and I'm joined today by Oliver Koo from the iOS build team at Pinterest. We've got a lot of great stuff to talk with you about today. Again, thank you for being here. We'll get started. So on the agenda for today, first we're going to talk about EC2, what it means, and the application development lifecycle. We'll then talk about where EC2 Mac, the instances, fit into that lifecycle, and also their specifications and benefits. I'll then hand it over to Oliver to talk about Pinterest and their specific migration journey. He'll discuss the challenges and findings that they found as part of their EC2 Mac journey. He'll go into a bit of a tech deep dive on setting up AWS auto-scaling groups with EC2 Mac and share some of his tips and tricks there. Lastly, we'll cover the integration with other AWS services that you get from using Amazon EC2 Mac instances. And we'll end with some Q&A and some next steps. So when we talk about Amazon EC2, Amazon Elastic Compute Cloud, one of the things that we really pride ourselves on here is the breadth and depth of our compute platform. We have a number of different categories or instance families, from general purpose, our M family, our burstable, which is the T family, compute, memory, storage intensive, even dense storage with our D family, GPU and graphics intensive families in terms of the categories. And when you combine that with all of the capabilities within those categories, you have the choice of processor, our own AWS Graviton processors, the latest and greatest from Intel and AMD, the speed of those processors, our up to 24 terabytes of high memory, storage, instant storage capabilities, accelerated computing options, networking, and all of these things. And when you combine these with the options of things like our block storage and our elastic inference for machine learning, this matrix ends up being more than 400 instance types. And really, it's there for every workload and business need. The breadth and depth of EC2 is really astounding and growing day by day. One thing we didn't have up until last year was the ability to talk to the Apple application development lifecycle. And this is for one big reason, is that the build, test, sign, and publish aspects of delivering applications to these Apple platforms, iOS, Safari, tvOS, etc., requires Xcode. And Xcode only runs on macOS, and macOS only runs on Apple hardware. And why is this important? Well, the breadth and depth of EC2 is amazing, but the Apple ecosystem is also just huge. 28 million developers, over 1 million apps on the app stores, 1 billion active devices. Some of you may even be watching this webinar on a Apple device currently. And so a large number of our customers really wanted the ability to deliver to these platforms within AWS. And so bringing these Apple developers to AWS required bringing macOS to EC2. And that's what we did. This is an actual photo of an actual Amazon EC2 Mac instance. And what you see here is a Mac Mini. This is an actual 2018 Mac Mini. If you had gone into an Apple store in 2018, when we started designing these instances, this is the exact same Mac Mini that you could have bought off the shelf at any store there. And what we've done is we've combined it with our AWS Nitro System, which is a combination of software and hardware, virtualization, and other features that allow us to provide a EC2 experience with this bespoke piece of Apple hardware. One of the things I like to point out on this picture is that this Mac Mini does not have any sort of lights out management. There's no SNMP or ILO or anything like that. So one of the things our engineers had to do is we actually have a little solenoid. You can't see it exactly in this picture. It's right under the word mini on this slide. But there's actually a little robotic finger that turns on and off the Mac Mini. And allows us to power cycle it programmatically. So I like to tell that as an example of the engineering work that's gone in to providing these EC2 Mac instances, to integrating this Apple hardware within the confines of Amazon EC2. So here are the specifications. It is, like I said, an Apple Mac Mini 2018 era. So it is an Intel Core i7 processor running at 3.2 gigahertz. And again, we have the Nitro system as a key component there. A couple of the features of Nitro that I will call out. We also have the Nitro security chip, which provides a hardware root of trust all the way back to the EC2 control plane. We also have the Nitro card itself, which provides through the Thunderbolt 3, which is actually PCIe under the hood port. The Nitro card provides network I/O and full monitoring for the system. And through this Nitro card, we can provide the 10 gigabits of network throughput and 8 gigabits of Amazon EBS bandwidth, in addition to the actual hardware, which provides 6 physical, 12 logical cores, and 32 gigabytes of memory. So let's talk about some of the benefits of EC2 Mac instances. The first one is it is fully managed, scalable Mac infrastructure. It is EC2. So because you can use your standard EC2 API constructs and existing EC2 mechanisms, you actually can scale up and scale down and allocate and use Mac infrastructure just like you would any other EC2 infrastructure, running your builds concurrently and really accelerating your time to market. You can also unify your DevOps pipelines. This is actually one of the bigger benefits for a lot of our customers who may already have pipelines within EC2 or AWS for Linux or Windows-based delivery. They can now add macOS to those same pipelines and really accelerate that pace of innovation because you're not treating Mac as a completely separate process. Both of those lead to developer productivity because once you integrate macOS with the rest of your existing AWS infrastructure or with the other services within AWS, there's so much less that a developer has to worry about. They have IAM for authentication and access controls, S3 as a durable object storage right there, VPC networking, CloudWatch for monitoring and insights, elastic block storage for durable, highly performant block storage. So instead of having to make these one-off decisions for Mac hardware, you can standardize and give developers the access and the control that they want to be productive. Lastly, especially in this day and age, we really see a lot of need for access to macOS from anywhere. And many customers had done this in a number of different ways throughout the pandemic. But we talk to customers all the time and they said, well, occasionally we would have to drive into the office just to power cycle a Mac, or we'd have to drive into the office to manually run an update or something like that. And that overhead, that management, it was not something that they particularly wanted to do. So with EC2 Mac, it's in the cloud. Your developers can be wherever they need to be, and they can access this EC2 Mac instances from anywhere. The end result here is that it takes away the need for these manual, invasive processes and allows you to focus on your core business and really accelerate your time to market to delight your customers. Let's talk about some of our customers that have deployed EC2 Mac instances and seen these benefits firsthand. First one I'd like to cover is Star Stable Entertainment. They make a tremendously kind of addictive horse game, Star Stable Online, live in 180 countries. And when they adopted EC2 Mac, they saw their build times decrease by 50%. They saw a massive increase in users during the pandemic, built a very steady community, and the maintenance of their physical hardware was really quite a drag, especially during this time of growth for them. And so by switching to EC2 Mac, they no longer have to maintain this physical hardware, and their staff is now significantly more productive and focused on building this entertainment company out across the various channels, and not just worried about, how do we make sure our builds are gonna work. Riot Games is also a video game developer and incredibly well known for their games like League of Legends. Legends of Runeterra is their latest game, a digital collectible card game set in the League of Legends universe. Riot had a fairly large physical on-premises presence of Apple infrastructure to build for iOS, but maintaining this physical infrastructure was a lot of work, and a lot of work that wasn't necessarily making the game any better, right? It was just getting the game out the door. And so by moving to EC2 Mac, they've been able to standardize 100% in AWS, parallelize their builds. They already had builds going for Android and Windows in AWS, and by folding macOS into this pipeline, they've been able to parallelize and really standardize these cross-platform builds. And again, now they can focus on being productive and innovating and really making Runeterra an amazing game, rather than having to maintain a stack of Mac Minis. I'll now hand it over to Oliver to go over the migration journey at Pinterest.
Hey, thanks, Scott, for the great intro on EC2 Mac. Hi, everybody. I'm Oliver, the iOS build engineer from Pinterest. Today, I'm here to speak to you about our continuous integration, short for CI, migration journey with EC2 Mac at Pinterest. For those who are not familiar with Pinterest, Pinterest is a social media app. Our mission is to bring everyone the inspiration to create a life they love. We have more than 450 million global monthly active users, 300 billion pins saved, and more than 2,500 employees globally. So at Pinterest, we're supporting a lot of engineers and a lot of builds every day. To kick off our migration journey, first let me tell you what we had before EC2 Macs were available. We had on-premise Mac Pro systems serve as our build machines. Our globally distributed team had to physically procure, configure, and upgrade these machines. We also need to provide additional monitoring to these machines due to their on-prem nature. Deploy fixes to these machines is not very simple. And often if something goes wrong, we had to reboot these machines, which can cause service disruption. Above all, the most limiting factor to our build throughput is that our build resources is limited. We can't just go spin up more machines in the middle of the day when we have more build demands. And with limited number of build workers, our organization faced a classic dilemma that many other organizations who also have limited number of build resource face. trading speed for stability, or vice versa. The more simulators your Mac run in parallel, the faster your builds will get done. However, it is a well-known phenomenon that the failure rate increases when more simulators run in parallel on Mac. On this screen, you can see this is a study done by Bitrise. And the bottom, you can see how when the number of simulators increases, the failure rate increases. In our case, we chose speed to handle the large amount of day-to-day build workload and let our on-call engineer handle failure cases as a workaround. This is not ideal, but now enters EC2 Mac. So with on-demand EC2 Mac instances, we have access to unlimited build resources. This gives us the flexibility to scale up our build cluster to fit our build needs while managing costs. And overall, after switching to building with EC2 Mac, we see an 18.4% speed improvement and 80.5 less build failures on CI pipeline that used to run by our on-premise machines. Oh, and we also see happier on-call engineers. But we can experience more benefits from EC2 Mac than just from its on-demand nature. A making upgrade now on our build cluster can be as simple as swapping AMI, which is a machine image that we use to run our EC2 Mac instances. We can easily find our previous machine images in our AMI registry too, so we can go back to the previous version of the build machines. And we now also have auto-scaling. We set up AWS auto-scaling group for each of our cluster paired with a scalar lambda function provided by BuildKite. BuildKite is a platform for running fast, secure, and scalable continuous integration pipelines on your own infrastructure. And at Pinterest, we use BuildKite as our CI platform. These auto-scaling lambda will pull on our configure cadence, and for us, we use 10 seconds, to adjust the desired agent count in your auto-scaling group. So our cluster size dynamically depending on the build demands. It typically scales up in the middle of the workday and dies down completely at night. And this effectively gives us a brand new cluster every new workday, which is like running a reboot. And we think this is the main contributing factor of a more stable CI build at Pinterest. We now also have centralized monitoring and metric using Amazon CloudWatch. We can see our build cluster CPU utilization, network throughput, and other agent metrics. With AWS, we can easily customize the privilege of our build clusters using AWS Identity and Access Management, also known as IAM. So we can give our different clusters different role and different policy attaching to those roles and have them perform different sets of jobs. I can give you more details later. And now we have version build cluster with launch template. Pairing launch template with auto scaling group, we can easily roll back or roll forward to a new version of the instances that will be launching in the auto scaling group. Now I want to share some challenge and findings. We're into many challenges along the way migrating our CI service into AWS. Here are a few notable ones that I think will be informative to others who is in a similar path. First, certificates and profile management. Apple's certificates, profile, and co-signing process is quite complex, but an essential part of the iOS development. You will want to avoid generating new certificates and credentials every time when you spin up a new EC2 Mac instances to avoid having hundreds sets of credentials in your Apple developer account. We use Fastlane to manage all necessary credentials on our CI machines and ensure they're in sync so we can keep one set of centralized credentials. Our build machine will pull a new updated credential, if there's any, from our certificate repository as part of our CI setup cycle. Unit test. At Pinterest, more than 50% of our iOS builds are integration UI tests. Stability is very important and challenging when it comes to iOS tests. When we first starting to build with EC2 Macs, we noticed that our UI tests have more flaky results throughout the day, meaning tests will require retry in order to pass. We'll also see a bit of increased test failures too. And this picture is an example of a pipeline that contains about 240 tests. And let me walk you through this picture. So from the bottom, you can see build 312 is the earliest job in the screenshot. And also I want to mention the commit in these jobs are just white space auto commits that trigger off the build. So the test content is essentially the same. The flaky test or failure are usually a result of something along the line of waiting for more resource to idle or waiting for network requests to finish in the logs. It is worth mentioning again that our EC2 Mac test cluster is set up to recycle every night, meaning new cluster is provisioned in the morning. So we thought maybe it's some memory issue or some build folder is not cleaned up correctly. We'll try all sorts of things, shutting down, erase, delete simulator between builds, cleaning out derived data and build folders, kill core simulator related service between builds, but nothing worked. Turns out it was because the machines were going to sleep, which explained the gradual instability we saw earlier. I think by default, the EC2 Mac instances go to sleep after 15 minutes. And so just simply by preventing the machine going to sleep solved our problem. And to do that, you just need this one line of code in your AMI. And voila, more stable UI test builds. Here's some other gotchas. On-demand cloud instance is not the same as on-premise machines. So running build in a non-login shell, you might run into these gotchas on Mac. Your CI agent likely needed to have full disk access enabled on your EC2 Mac instance's security and privacy setting. Launching your build agent from user login sessions seems to give your build agent elevated privileges compared to running your build agent as a service. I assume many of us won't be manually logging into EC2 Mac instances to launch build agents in the morning. So if you run your build agent as a service, you will want to give your build agent elevated privileges by granting an FDA. Otherwise, you'll run into a scenario where you see inconsistency between builds that you launched when you SSH into your EC2 Mac instances and run a job and it passed and you thought it's going well. And then when you actually run a CI pipeline automatically using your build agent as a service, the job failed. iOS CI jobs often need to run and test in the iOS simulator. To do this, Mac need to be logged in as user, and the build agent needs to be started as part of that session. We can achieve this by running our build agent as launch agent with user session. By using launch agent, build will be able to perform UI interactions, making it possible to run and test in the iOS simulator. Another frequent component of iOS CI jobs are running code sign and assessing your keychain where you store your certificates. Code sign is a pretty sensitive bit of Mac OS and require elevated privileges to access to. Running build agent as launch agent with a user session give your build agent permission to do exactly just that. So now you can run code sign as part of your builds. Since launch agent will be running only when the user is logged in, you should enable auto login on your Mac OS machine. So every time when your EC2 Mac is up and running, the build agent will automatically be launched. It's worth noting that Mac OS also has launch daemons, service running completely in the background. Launch daemons are run on system startup, but they don't have the same access to UI interactions as launch agents, meaning your build won't be able to run the UI tests we mentioned earlier. We'll also likely get some error when you try to access your keychain. We went down that path, so I'm hoping people can avoid it by mentioning it here. Now you know our migration journey, let's take a deeper dive on how to set up a EC2 Mac instances auto-scaling group in AWS using Terraform. We use Terraform at Pinterest to manage all AWS resources for our iOS build infrastructure. For those who doesn't know Terraform, it is an infrastructure as code software tool that provides a consistent CLI workflow to manage cloud services, including AWS. In Terraform, there are resources. Resources are the most important element in the Terraform language. Each resource block describes one or more infrastructure objects, such as virtual networks, compute instance, or high-level components such as DNS records. You can think that a Terraform resource block mapped to an AWS resource. EC2 Mac instances need to run on dedicated hosts. We first need to create a license configuration, which you can use to configure your eligible software license from vendor, such as Microsoft, SAP, etc., onto your dedicated host. For the purpose of this demo, let's create a core license that we can use to enforce limit on number of cores that our dedicated host resource group can launch. So here you can see on the code that this is a resource group, and this is just saying, hey, using the resource group, call AWS License Manager license configuration, and then you can call it whatever name you want. So we can refer this later as AWS License Manager license configuration dot demo license later on. And then I give it a name called demo iOS build and license counting type core. Next, let's create a dedicated host group. The Terraform code for this is quite long, so I didn't include in the slides, but I will show you later in the live demo. And it's worth noting that you can also create a resource host group manually in your AWS console pretty easily. Now we have a license configuration, we can continue to set up a dedicated host group that can launch new dedicated hosts if autoscaling group needs it. The Terraform code for the dedicated host group is quite long, so it won't fit on the slide. So I didn't include it here, but I will show it to you in the live demo, and then I'll share a link at the end of the presentation. I also want to note that you can easily create the dedicated host group in AWS console pretty easily. Now we have created the dedicated host group and the license configuration. We can use that to create a launch template, which then can be used to create an EC2 Mac instance autoscaling group. In this launch template resource block, you can see that I say, hey, this launch template should launch an instance type such as Mac1.metal, which is the EC2 Mac instance type. And here I'm using the license configuration that we created earlier in the license specification block. You can see I refer it as AWS License Manager license configuration .bilkai iOS agent .arn. ARN just means it's Amazon resource number, so you know how to find that resource in AWS. Placement. With the placement has to be tenancy host, which just means, oh, these instances have to be launched on a dedicated host, and then we use the host resource group that we just created. Lastly, finally, the final step is create an autoscaling group, and here's the code. You can configure autoscaling group to launch instances using particular version of your launch template. This is how we can easily roll back our cluster to the previous version or roll forward to the next one by changing the default version of the launch template that autoscaling group uses. Now we'll briefly walk through the code. Let me show you how this works in action. Demo time. Okay, so this is a AWS account I created for the demo purpose. And here are the code that we just walked through in the presentation slides earlier. So as you can see, in this newly created demo account, there's no autoscaling group. There is no launch templates exist yet. And so we're going to use Terraform to create that like we just did. We'll walk through in the slides. So if I do Terraform plan, it's going to tell me, hey, what if I apply all these resource blocks on the left, what will be created in AWS console? And it's telling me, oh, hey, I will create all these resources, like such as AWS launch templates. I will create the resource host group, the autoscaling group, or license managers. So now if I do a Terraform apply, it will try to create those for me. I have to say yes. Make sure that I actually want those resources. And while this resource is creating, let me show you how the code for the dedicated host resource group. So unfortunately, Terraform doesn't have a resource group that's dedicated to the host resource group. But what we can do is we can use AWS CloudFormation to create it. AWS CloudFormation Stack is a service that helps you model and set up your AWS resources. You create a template and that describes all the AWS resources that you want. And CloudFormation take care of the provisioning and configuring those resources for you. Now the Terraform is done applying. If we go back and just refresh this page, you can see, hey, there's a launch template here. And also I want to show you the license configuration we made. So if you go to AWS License Manager, you can see now, hey, there is a license configuration called demo iOS build, which is what we called it earlier, demo iOS builds. And you can also see the host resource group that we created. There's a host resource group, which is created with Terraform. And now if we go back to the EC2 console, you can see the launch template we created, and you can see this launch template being used. If I copy this, being used in the auto-scaling group here. Auto-scaling group named iOS. And if we click into it, you can see like, oh, hey, the launch template it is using is this exactly, the one that we just created. And to show you some kind of operation you can do with this with Terraform is that because it's modularized, you can easily apply changes that you want to do. So for example, here in our launch templates, you can go back to launch template. I'll make it slightly bigger for you guys. You can see that, oh, hey, it's paired with an AMI that's 50059FF8. If I copy this AMI, we can find out what it is. I already know what it is. That based on our code is saying like, hey, the AMI you were using is based on this data block above. And then this AMI is created by searching through the AMI registry with using the filter of Amazon-EC2 Mac OS 11.4. So if I look that up again, I should see the exact same AMI name. There we go. And it's using the latest. So because here it's saying use most recent. So then the AMI name should be the most recent one, which will be this one, 059FF, which is a later version. You can see the date is later. It's 2021 July. Okay, so now if I say, oh, I want to upgrade to a new Mac OS version. Say I want to upgrade to a new Mac OS. Let's see what's available out there. Amazon EC2 Mac OS. Let's see, I want to upgrade to, I don't know, the latest one, which is I think 11.6. Let's use this one. I can instead of using the filter, I'm going to just directly using the AMI here. So I'm not using this data block anymore. Let's just change it directly to this. I'll quote it, and now go back to Terraform. Bring up the code. Bring up the console again. I'll clear this. So now if I do Terraform plan again, you can see that, oh, some changes that it's doing, it's like, oh, I'm changing your launch template to a new AMI that you just specified from the earlier one. I'll make that bigger. And I'll make this basically a new version. When you make edit to a launch template, it automatically create a new version for you. So now let's apply this. Yes. What's applying? I'll make this a little bigger. So now I'll go back to our launch template. Now the application is applying is done. If I go back to the launch template, I can see now there are two versions. And the second version is the AMI that we just applied, 0A3E6. 0A3E6, perfect, version 2. And then note that the auto-scaling group, because it's paired with this launch template, and you can see that in our auto-scaling group that it's using the latest of the launch template. So say if we're in production, now I'm done testing this new AMI that has a new upgraded macOS environment. And I was like, oh, that looks great. In the testing environment, I want to now upgrade to production. What I can do easily is just go to the launch template, set default version, set to the latest version to be default. And voila, now the second version of the launch template is the default. So auto-scaling group will start launching this if we start launching instances from the auto-scaling group. And that's how we create auto-scaling group with EC2 Mac using Terraform. And I promised earlier to talk deeper about other benefits beyond the EC2. Pause. Say that sentence again. Drink a sip of water. I promised earlier to talk deeper about other benefits beyond the EC2 Mac instance itself. These benefits come from other AWS services within the AWS ecosystem that now we have access to after migrating to AWS. We use AWS Secret Manager to managing all our credentials and secrets that's used in the iOS build platform. The AWS Secret Manager store and rotate our credentials for us. And this means we don't need to integrate a third-party solution. We have to authenticate it somewhere else to grab credentials for our builds. We use AWS Identity and Access Management, IAM, to give different cluster different permissions. So we have create sets of different policies, and then we'll attach those policies to the role that's used on those EC2 Mac instances. So for example, our release cluster will have special privileges to access to certain credentials that's needed to publish app version to the App Store, where the other cluster, like the test cluster, does not need that permission. We use Amazon CloudWatch to get centralized metric to see CPU throughput or network throughputs, and also some of our agent metrics. We also use Amazon Simple Notification Services, known as Amazon SNS, to set up lifecycle hooks, paired with our auto-scaling group. These lifecycle hooks runs on agents before it's ready for services when it spin up, and before it's terminated when it spins down. So these lifecycle hooks are particularly useful to do warm-up and set up the agents when the agents spin up, such as install the right tools and libraries, and with spinning down before it terminates itself, we can collect metrics on it. We use AWS Lambda, like I mentioned earlier. We run the build kite agent scaler to automatically adjust our build cluster, depends on our build demands. We also use Amazon Elastic Block Store, which is known as EBS. So now we can easily adjust the storage size of our cluster to fit our needs. We can also leverage EBS snapshot to back up our data whenever we want to. So here's a migration summary. We saved some money along the way. So now it's actually cheaper to run these EC2 Mac clusters in AWS compared to on-prem setup. We simplified our build infrastructure. Now it's much easier to understand and reduce the upgrade time by 43%. So like say upgrade to new Mac OS, like I just demoed, it's much, much easier. It's a faster build compared to our on-prem setup. We see 80.4% speed improvements. We now have fresh build fleets, which give us more stable builds. We see an 80.5 reduction on build failures that's related to CI issues. Last but not least, we're able to integrate with other AWS services in the AWS ecosystem and leverage those resources to modernize our build pipelines. And now it's time to give some acknowledgement and thanks. I'd like to thank these individuals and teams that are from at BuildKite, Pinterest, and AWS. They have been giving me support along the way, and our CI migration journey to EC2 Mac wouldn't have been possible without the help of these folks. And especially want to thank Garrett Moon, who is the iOS platform tech lead at Pinterest. He had given me unparalleled support since I joined at Pinterest and started the project. I couldn't have done it without him. And finally, I'd like to thank the iOS community. By no means we did any groundbreaking work here today. All the work we presented today are works coming from the community. iOS CI builds have many challenging issues, such as dealing with security, certificates, Xcode installations, and updates, and the communities have been working on solving these issues for years now. What the team and I did here today is just putting these stories together and findings that we got from different parts of the internet together. AWS being the first major cloud provider supporting Mac OS instances makes Mac machines more readily available and accessible for iOS developers. And I'm hoping this will foster a centralized environment for the iOS developers to come together and further standardize iOS build for the industry.
Thanks, Oliver. That was awesome. If you want to learn more about EC2 Mac instances or even try them out, we do have a Getting Started guide on GitHub under the AWS Samples organization. It's called Amazon EC2 Mac Getting Started. Please check it out. It has a lot of great information about the platform, about how to allocate and launch an instance in your own account. The demo code that Oliver shared is also on GitHub in this gist for the Terraform piece. We also have some really great tutorials up on YouTube. If you just search for Amazon EC2 Mac Tech Tutorials, there's a series of 3 5-minute tutorials narrated by yours truly, so they're great. Please check them out. And lastly, we do have a hands-on tutorial under the Getting Started/hands-on section on aws.amazon.com. If you search there for Amazon EC2 Mac, it'll come right up, and that will actually walk you through from literally launching the console all the way to being able to SSH into an Amazon EC2 Mac instance. Thank you. Thank you for your time today. Thank you for your attention. Please check out those resources. And again, we really appreciate your attending this webinar. We are very excited about EC2 Mac instances. We are excited about finally bringing Mac OS to AWS. And we'd love to hear your thoughts and hear how you're planning on using it and your successes with it. And with that, I will go ahead and open it up for any Q&A.